That's the end of work, power and energy. This section is about electromagnetic effects. Electricity, magnetism and movement are all linked. First, let's remind ourselves about the properties of magnets. As you watch the next clip, note down some of the properties of magnets and magnetic fields.
A magnet doesn't have to be touching whatever it's attracting, like this paper clip. The force of the magnet can be sensed all around the magnet, and this space of attraction is called the magnetic field. Now, the magnetic field is invisible to our eyes, so how do we see it? Well, these small pieces of iron are called iron filings, and they line up in the shape of the magnetic field. And where the lines are closest is where the force is strongest, at the ends of the magnet, at the poles. This is only part of the picture. Magnetic force doesn't just work in air. The iron filings have been mixed with oil. And drop in the magnet, we can see the shape of the magnetic field all around the magnet. The iron filings are closest together at the poles, and that's where the magnetic field is strongest. Further away from the magnet, the filings are wider apart, and that shows that the magnetic force decreases the further away you are from a magnet.
We saw that magnets can exert a force on magnetic materials without touching them, so magnetism is a field force, not a contact force. The area around a magnet where the magnetic force acts is called a magnetic field. Lines of force point away from the North Pole towards the South Pole. Lines of force are closer together where the field is stronger and further apart where the field is weaker. Opposite poles attract each other, while like poles repel each other.